Hello everyone. Today we will be introducing the Aqueous solutions to all of you guys. Aqueous solutions are solutions that are made up of a solute or more than one solute, and the solvent has got to be water. The reason why we call them aqueous solutions is because they've got the water as the solvent. Now the solvent is the substance, which is in this case water, that is responsible for dissolving the solute in it. In this concept, we have to tackle two very important quantities of solutions. We've got the molar concentration represented by capital C and the mass concentration represented by Cm, capital C and small m. Looking at the two expressions down below, C equals N divided by V, Cm equals M divided by V, which means that N equals C times V and M equals Cm times V, where C is the molar concentration of the solution represented with the units mole per liter or mole times L to the power minus 1 or simply capital M. N is the number of moles of the solute and its unit is the mole, and M is the mass of the solute expressed in grams, and the VL is the volume of the solution, and it has to be expressed in liters. A small notice to be passed on here. If you want to convert from milliliters to liters, all you need to do is divide the milliliters by 1,000 to get it to liters. And if you want to convert the liters into milliliters, ladies and gentlemen, you need to multiply the number of the liters by 1,000. Now the relation between C and Cm. C equals to Cm divided by the molar mass of the solute, and the Cm equals to C times the molar mass of the solute. By the way, the unit of the molar concentration is mole per liter, while the unit of the mass concentration is simply gram per liter. Now, the next slide here, it shows some very easy concepts to deal with. The mass of the solution is equal to the mass of the solute plus the mass of the water, which is the solvent in this case. If you have, for example, 2 grams of salt and you dissolve them in 20 grams of water, logic tells me that the mass of the solution has got to be 22 by simply adding 2 to 20 to end up with 22. The density of the solution is equal to the mass of the solution divided by the volume of the solution. Usually the units that we deal with when it comes to the densities of aqueous solutions are usually gram per milliliter. Mix of solutions. In this section of the lesson, we need to deal with two different mix of solutions. Part A is when we have solutions with the same solute, and part B is when we mix solutions with different solutes. Let me start with part A. Part A, we have 2 beakers, beaker 1, beaker 2. In beaker 1, we have sodium chloride solution with C1 equals to 0.2 mole per liter and V1 equals to 60 milliliters. In beaker 2, we have the same solute, which is NaCl, and leading to the same solution, sodium chloride solution, but they have C2 equals to 0.35 and V2 equals to 20 milliliters. The question is, we need to determine the molar concentration of the final solution upon mixing the contents of beaker 1 with the contents of beaker 2. You start by writing down N1 plus N2 equals N final. N1 are the number of moles of the solute in beaker 1. N2 represent simply the number of moles of the solute in beaker number 2, and N represents the final number of moles of the mix of the two of the solutions. Now, as you recall previously, we said if C equals N divided by V, so N equals C times V. So instead of writing down N1, we wrote down C1 times V1 plus C2 times V2 equals C times V. Remember, our objective is to determine the molar concentration of the final solution, which is C. So you plug in the numbers. C1, you put 0.2, times V1 60 plus C2 you put 0.35 times V2 which is 20 equals to C times 80. Where did I come up with the 80? The 80 is simply the volume of the mix. When you mix 60 milliliters with 20 milliliters, you have to end up with 80 milliliters. You run a small arithmetic operation to calculate C. C comes out to be 0.2375 moles per liter, which represents the final molar concentration of the mix of the two solutions together. Some students ask me, why didn't you convert the volume in this case into liters? My answer to them was the following. If you have C expressed in mole per liter and the V expressed in milliliter, when you run the operation of some arithmetic operation here to end up with the C, you notice that all of the units, they cancel out. So you have mole per liter times milliliter, mole per liter times milliliter. On the right side, you also have mole per liter times milliliter. So the milliliters, they all cancel out and you end up with the unit mole per liter for the final C. Now the next slide right here, it shows the solutions that we have different solutes mixed together. Great application given here. We have a solution of CaCl2 with C1 equals 0.2 and V1 equals to 50 milliliters mixed with a solution of AlCl3 with C2 equals 0.4 mole per liter and V2 40 milliliters. The question is, in this application, we need to determine the molar concentrations of all the ions that we have in the final mix. Now guys, when you mix calcium chloride with aluminum chloride solutions together to end up with a final solution, in this final solution, you gotta have Ca2 plus ions, Cl minus, and Al3 plus ions. Our objective is to determine the number of moles of each one of these ions in the mix, then divide those number of moles by the total volume of the mix in order to determine the molar concentrations of all ions we have in the mix. So we start with the number of moles of Ca2 plus. Ca2 plus is coming from CaCl2. So we put C1 times V1 times 1. The reason why we place times 1 is because if you look at the formula unit of calcium chloride, you only have one calcium in it. So plugging in the numbers, 0.2 times 0.05 times 1, you end up with 0.01 moles for Ca2 plus. Now, why did I put 0.05? The reason why this is placed is because I want number of moles of the Ca2 plus. So if you look at the units, mole per liter times liter, the liter and the liter, they both cancel out, ending up with the mole as the sole unit. The N of Cl minus in calcium chloride is C1 times V1 times 2. Again, the reason why we have times 2 is because in CaCl2 we have 2 chlorides. So you plug in the values, you end up with 0.02 moles for Cl minus that derives from CaCl2. Looking at the next solution, which is AlCl3, we put N of Al3 plus equals to C2 times V2 times 1. Again, the reason why we multiply that by 1 is because in the AlCl3 we only have one aluminum. So the number of moles of the Al3 plus comes out to be 0.016 moles. Now, the number of moles of the chloride ions that are derived from the AlCl3, it's C2 times V2 times 3. The reason why we place times 3 is because we have 3 chlorides in the AlCl3. Plug in the numbers, you end up with 0.048 moles. Now, finally, you open bracket and you put Ca2 plus inside the bracket. The bracket, ladies and gentlemen, is usually used when you express the molar concentrations of ions. Ca2 plus is an ion, so you place it in bracket. The bracket denotes that this is the molar concentration. Equals to N divided by V. We put the number of moles of Ca2 plus 0.01 divided by 0.09. Now here's the big question. Where did I come up with the 0.09? When you mix these two solutions together, the final volume is 50 plus 40, you got 90 milliliters. So 90 milliliters, divide that by 1000, it comes out to be 0.09. So the molar concentration of the Ca2 plus is 0.11 mole per liter. The Cl minus, we have two sources of the Cl minus. We've got 0.02 coming from the CaCl2 and the 0.048 moles coming from the AlCl3. So you add up those two number of moles of the Cl minus, divide them by the total volume, which is 0.09. The answer comes out to be 0.76 moles per liter. Last but not least, the concentration of the molar concentration of the Al3 plus equals to N divided by V. N is 0.016 divided by 0.09. The answer comes out to be 0.17 mole per liter. Please, ladies and gentlemen, I strongly urge you to solve in the book on page 33, numbers 1, 2, 3, and 4. Those 4 exercises are simply very much application exercises on the concepts that were discussed in this session. Thank you so much and God bless.